Hey, boys and girls, back for another episode. Gonna try to go through this quick today. We're gonna basically do the same thing we did last week, except we're gonna flip it around. What I mean by that is last week we looked at this and we said this used to be 1/2, right? That was our original starting fraction. And then we chopped each piece up into one, two, three, four pieces. Again, we had one big one out of two. We chopped each piece into four. Again, both our one colored one and our two regular ones. And then our new fraction was 4/8. And really, for the next couple of days, we're going to do that same exact idea. We're just really going to flip our equation around. And what I mean by that is we're basically going to just do it in reverse. We're going to start over here. Like basically, again, I would always say last time, again, what was it at the beginning? How did we change it? What is it now? Flip that around. What is it right now? Right now, it shows 4/8. Okay, instead of multiply, what's the opposite, or what we call the inverse? I always talk about like reverse, it cancels it out. Of multiply is to divide. We're still going to divide by the same thing. And then that would get us back to the 1/2 where we started. Or in a way, you can basically think of it the other way. Now we're taking those red lines away. I don't know if I can actually take them away. Nope. A different program, I can kind of just do that. Right? Again, I'm always thinking about, again, when I'm kind of trying to figure it out, a lot of times what I'm dividing by, if it works, is the top number. If the top number goes into the bottom number, that's a good place to start. Okay, because the only things I can divide 4 by are 4 and 2. Obviously, 2 would get me to, 2/4 if I did it by that. But again, I would only get rid of the top and the bottom line, but not the middle. I want to get rid of, if I can, all the lines going across. And I'll show you another example of that in a second. I just have to redraw a new picture on the board. Okay, so another example. Again, this will be more for what we're going to do tomorrow, which will be Thursday for you guys. I know I make videos at different times. Again, I had a rainbow pen. You got to use it. So again, how much is colored in out of how much? Again, only really difference today is, again, last week, we called this, we started with 1, 2, 3, 4, 5 big pieces out of 6. Right? How did we chop it up? We cut each box into 2 smaller boxes. And we ended up at 5 times 2 makes 10, top times top. 6 times 2 makes 12. Again, you notice that in both of those. Again, the other one was 4/4 in the middle. This is 2/2 in the middle. As long as I have the same number on the top and the bottom, that's how I'm changing my fraction. Okay? Fractions are equivalent when both pieces change the same way. I talked about it in a previous video because this is really the number 1. And any number times 1 equals that regular number. It's just the numbers look different. 5 and 10, 6 and 12. Again, you notice my rainbow color here is the same amount of space, so the same area of the candy bar or the mile or the race or the whatever was in the question. All we're doing is flipping it around the other way. Okay? And again, I talked about in the last half of the video, the two things that I always start with are, can I use the top number itself? If I'm doing 10/12 and I want to simplify it, I look at the top number first. Obviously, 10 isn't going to work. I can't divide 12 by 10 evenly. The other thing I look for is the gap between the two numbers, or the difference between them, meaning how much bigger is 12 than 10. It's bigger by 2. A lot of times that will be the number that we're going to use. Okay, like the other one was 4/8. 4 worked with 4 and 8. That's a good one. Here, I look for the gap between them. Really, my number, I can't use like a number like 4 because that's bigger than my gap itself. Okay, so again, 10 and 12. What I can divide both of those by, remember that's the inverse of multiplication against the same numbers. I'm going to divide it by 2 and 2. And then I end up with 5, 6. That would, again, just be, imagine this red line in the middle if I just was able to erase that. it would go back to its original. So again, I talked about that in the last part, right? This is what it was. This is how we change it. This is what it is now. Just flip that around. What is it now? Right now, it's 10 little pieces out of 12. We're going to pull apart by 2, and then there's 5 and 6 left. And it's just what we did last week, but the opposite way. It is a little trickier to think about. Again, those are the two things that I always look for. I always look for the top number first. I say, can I just divide both numbers by the top number? Right, like I did with 4/8. 4 goes into both 4 and 8. I can't find a bigger number to use than that. Or again, if that doesn't work, like with 10 and 12, I look for the gap between them. The gap between 10 and 12, is 2. Or similar if I was doing something like 10/15. Do that over here. Again, I'm looking, I'm saying, well, how far apart are 10 and 15? Oh, they're 5 apart. Let me see if that works. And it does. So it won't always work, but again, in this case, it does. I'll use my Galaxy pen, right? The gap between 10 and 15 is 5. So that's the number that I'm going to divide both pieces by. Again, here the top number itself worked. That's a better solution if that does. If it doesn't, then check that gap. 10 divided by 5 is 2. 15 divided by 5 is 3. So see what I mean? That's the space between 10 and 15 is 5. That's the best common factor, or the greatest common factor I can use. If the top number itself works, like it did with 4 and 8, use that. You won't be able to find a bigger number than the top number itself. All right, hopefully this was helpful. I was trying to keep it a little shorter because it's Wednesday, and I know we're a little tighter on time. We're going to go over this again tomorrow, and then we'll work more on this stuff on Friday. All right, I will see you in a little bit.